Okay, guys, so what we're going to do today is we're going to talk about the kind of final tail end of 4-5b, putting it all together. So what we're going to start off with today is the idea of what's called a phase shift. So a phase shift is basically moving a function left or right, specifically a trig function. The best way to find out a phase shift is to take the inside of your trig function. In this case, say we have sine of bx plus c. We're going to take this inside function and set it equal to 0. Whatever we end up getting is going to tell us how much we're shifting left and right. So let's go ahead and practice this. So for our first example, let's start with sine of 2x plus pi. I'm going to go through and define all of the pieces that I need to know in order to graph a sine or cosine function. So the first one is this, the amplitude. The amplitude is basically how tall the function gets from the midline or how far down it goes from the midline. The amplitude can be found by looking at the coefficient in front of the trig function. In this case, the coefficient is assumed to be 1. So we can say that the amplitude is 1. From there, we're going to talk about the period. The period of a function is how long it takes for the function to start over. The best way to find a sine and cosine period is to take 2 pi and divide it by b. B in this instance is always the number in front of x. And so we're going to take 2 pi and divide it by 2 to give us pi. So our period is pi. The best way to scale a function is to create what I call quadrants. So in order to find a quadrant, all you're going to do is take your period, which in this case was pi, and you're going to divide it by 4. So our quadrants are going to be pi over 4, which means we're going to scale by pi over 4. All right, second to last one here, we want to talk about vertical shift. Vertical shift is if I add or subtract to the outside of the function, which that does not happen, so there is no vertical shift here. Last one, phase shift, which is what we're talking about today. The phase shift does happen here, and I know it's going to happen when I set the inside equal to 0. So we can say that 0 is equal to 2x plus pi. Subtract pi on both sides. And we'll get negative pi is equal to 2x. If I divide by 2 on both sides, I get negative pi over 2 is equal to x. So what this actually means in words is this. I'm going to move the function left pi over 2. Okay, at this point, I know this is a lot of information, but this is all the information that we need to graph. So I'm going to go ahead and take this information, and I'm going to kind of place it somewhere so that we can all see it. So let me go ahead and take this information, and we're going to move it to the next screen. All right, so I'm just going to kind of keep this off in the corner here. All right, so in order to graph this function, the first thing I want to start with, order of operations-wise, is the vertical shift. There is no vertical shift, so I'm going to assume that my midline starts on the x-axis. So we don't have to change that there. The next thing that I want to do is talk about the phase shift. We need to move left pi over 2. Well, in order to find out how much pi over 2 is going to be, let's go ahead and scale our graph. So I'm going to scale it by pi over 4. That means every tick mark is going to be pi over 4. So we'll say pi over 4, and I'm not even going to simplify here. I'm just going to say 2 pi over 4, 3 pi over 4, and 4 pi over 4. I'm going to go to the left too. Okay, so once we have all of our scaling up, let's go ahead and talk about the y-axis scaling. Because my amplitude is 1, I'm going to just go ahead and scale the y-axis by 1. So 1, 2, 3, negative 1, negative 2, and negative 3. All right, so from there, I want to go ahead and focus on the phase shift. The phase shift says that I'm moving left pi over 2. So traditionally, my function is going to start at the y-axis, but because I have a phase shift, I'm going to shift it left pi over 2. Notice here, 2 pi over 4 is the same thing as pi over 2. So this is negative pi over 2 here. So I'm going to shift to the left. The next thing I want to focus on is what does a sine function traditionally look like? So we took a memorization quiz on basic sine and cosine functions. So we should have a good idea of what sine functions should look like. Traditionally, sine starts on the midline. And traditionally, sine also starts at the origin. But because we're shifting to the left pi over 2, we're actually going to start sine still on the midline, but we're going to shift it left pi over 2. So this is where sine's going to start. I'm going to go ahead and create some quadrant lines here so I'm kind of reminded of where all the important pieces of my graph are going to happen. So I'm going to put a quadrant line after each tick mark here. And these quadrant lines, once again, are just to kind of remind me, hey, important things happen here and here and here and here. All right, so the sine function starts on the midline. After that, the sine function goes up to a maximum. Specifically, I'm only allowed to go up 1 because my amplitude is 1. So because my amplitude is 1, I'm going to go to the next quadrant line, and I'm going to go to a maximum of 1. So everything important is going to happen on these quadrant lines. From there, I'm going to go to the right one more quadrant. I'm going to come back down to the midline. I'm going to go down to a minimum at my next quadrant line. Remember that my amplitude is 1, so I can only go down 1 to -1. And then I'm going to come back up to the midline, and I'm going to connect these with a smooth curve. So this is the sine function, except it got shifted to the left pi over 2, and we changed our period from 2 pi to pi. So if I want to extend this a little bit so that I have a little bit more information, the pattern would extend like this, okay? So that's our first example. Let's go ahead and move on to our second example. All right, so we have 2 cosine of x over 2 minus pi over 4. So we're going to start with the first question. What is the amplitude? Well, the amplitude is the number that is in front of the trig function. In this case, it's being multiplied. It's always going to be multiplied. It's going to be 2 over 3. So the amplitude is 2 over 3. Next, what I want to deal with is the period. The period is always 2 pi over b for sine and cosine functions. So I'm going to say 2 pi divide by, okay, b is a little harder to see here. X is being divided by 2. So what I want to do is I'm going to rewrite this as 1/2 x. X divided by 2 is the same thing as 1/2 x. So my b value must be 1/2. So this is going to be 2 pi divided by 1/2. If we do this thing called keep it, switch it, flip it, which is when I divide 2 fractions, I'm going to keep 2 pi the same. I'm going to change the division sign to multiplication, switch it, and then I'm going to flip 1/2 to 2 over 1, which is going to give me 4 pi. So my period here is 4 pi. If my period is 4 pi, then my quadrant is going to be my period, which is 4 pi, divide by 4. Well, if I divide 4 pi divided by 4, my quadrants must be pi. All right, second to last one here, the vertical shift. Is anything being added or subtracted to the outside of the function? The answer is no, there is no vertical shift here, which just leaves me with a phase shift. So the phase shift is going to be when I set the inside of my function equal to 0. So 0 is equal to x over 2 minus pi over 4. If I add pi over 4 to both sides, I get pi over 4 is equal to x over 2. Multiply by 2 on both sides, and we'll get pi over 2 is equal to x. So what this means is this time we're going to go right pi over 2. All right, so what I'm going to do is I'm going to take all of this information, and we are going to bring it to the next page. I cannot see my mouse at all right now. Here we go. Nope. Here we go. All right. All right, let's go ahead and move this information to the next page. All right, so what I want to start with is my scaling. So according to what I know about my quadrants, I need to scale this by pi. So I'm going to go ahead and make each tick mark equal to pi. So pi, 2 pi, 3 pi, 4 pi, and then we'll also go negative. Okay, so from there, I want to go ahead and acknowledge, so we did our quadrant lines. Let's go ahead and see if we need to do any vertical shifting. We don't, which means the midline is going to stay the same. It's going to stay the x-axis. After that, I want to go ahead and take a look at the phase shift. The phase shift says we're moving right pi over 2. Okay, well, in this case, pi over 2 is going to be somewhere between 0 and pi. So I need to shift right about half a quadrant. And I'm actually going to create a quadrant line halfway through each tick mark here. So from there, each quadrant needs to be pi in distance. So the next quadrant line is going to be half a pi plus another half a pi distance away, which is actually going to land me in the middle again. So we're actually going to be in the middle for all of our quadrant lines because we got shifted by half a pi. All right, so we should have 1, 2, 3, 4 quadrants. Let's see, 1, 2, 3, 4 quadrants. And we should be good to go to start this. So what I want to do is focus on the next piece, which is that this is a cosine function. Cosine starts at a maximum. The maximum value is going to have to be 2 over 3 away from the midline. So if I scale this, let's go ahead and scale this by thirds because I think it'll be easier. So I'm going to make this 1/3, I'm going to make this 2/3, -1/3, and -2/3. So cosine starts at a maximum. Normally cosine starts at 1, but this time cosine needs to start 2/3 away from the midline. So I need to go a distance of 2/3 from the midline, which is going to land me right here on my first quadrant line. So I'm going to start at a maximum of 2/3, and I'm also going to shift to the right pi over 2. From there, once we have all of this set up, it should be pretty easy to find the solution. So what I'm going to do next is I'm going to go over one quadrant line and go back down to the midline. So cosine starts at a max and goes down to the midline. From there, I'm going to go over another quadrant line and I'm going to go down to a minimum. Remember that my amplitude is 2/3, so I am only allowed to go down 2/3. From there, I'm going to come back up to the midline, and then I'm going to end again at a maximum. I'm going to connect this using a smooth curve. And this right here is 1 period of the cosine function. If its amplitude is 2/3, its period is 4 pi, and it is shifted to the right pi over 2. Okay, so let's move on to our very last question. So our very last question here is going to be 4 sine of 2x plus pi. So the first thing we're going to start with, like we have the whole time, is the amplitude. All right, so the amplitude is the number that's in front of the trig function. We can see the number in front of the trig function is actually, it's not 4, it's the number being multiplied to the trig function. 4 is being added. So the number in front of the trig function that's being multiplied is actually 1. So my amplitude here is 1. All right, from there, let's go ahead and find the period. To find the period, we're going to take 2 pi and we're going to divide it by b. So this is going to be 2 pi divided by the number in front of x, which is 2, giving us a period of pi. To find the quadrant, we're going to take pi, our period, and divide by 4. For the vertical shift, there actually will be a vertical shift this time. Is the number being added or subtracted to the function. We added 4 to the function, which means we need to go up 4. Lastly, for the phase shift, we're going to set the whole inside equal to 0. So 0 is equal to 2x plus pi, subtract pi, and we'll get negative pi over 2 is equal to x, which means we need to move left pi over 2. Okay, so let's go ahead and graph this. So I'm going to go ahead and put the information off to the side, kind of for our reference. And we're going to go ahead and graph this. All right, so on this new graph, and actually in class today, we only graphed the first one on our notes and the rest we did on a whiteboard. So if you're running out of room, that is completely normal. We're going to start with the quadrant. The quadrant should be pi over 4, so this will be pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. We're also going to go negative. Okay, so from there, the next thing I want to focus on is my vertical shift, which we haven't seen until just this example. Because we have a vertical shift of up 4, I'm actually going to scale this by 2s. So I'm going to say this is 2, 4, 6, 8, just so it fits. Because we have a vertical shift of 4, that means that my entire function is going to be shifted up 4, which means we're going to have a new midline at 4. So we're no longer going to orient everything on the x-axis. We're going to orient on the midline. So the midline has been the x-axis for the last couple of examples, but now the midline is up 4. From there, I want to go ahead and talk about the phase shift. The phase shift says that we're moving left pi over 2, which means from the y-axis, I need to go left pi over 2, which we might remember here. 2 pi over 4 is the same thing as pi over 2. I'm going to go ahead and set my quadrant lines up at negative pi over 2, or negative 2 pi over 4. And then from there, I'm going to set quadrant lines up at each tick mark because I started my first quadrant line on a tick mark. All right, so I want to make sure I have 4 quadrants, which 1, 2, 3, 4. I have 4 quadrants. Perfect. All right, so all I need to do is start this. This is a sine function. So remember that sine functions start at the midline. So I'm going to start at the midline, but the midline is no longer at the origin. The midline got shifted to the left pi over 2, and it got shifted up to this new midline here at 4. So this is my new starting place. From there, I'm going to go right 1 quadrant line, and I'm going to go up 1 because my amplitude is 1. So because I scaled this by 2s, I'm only going to get to go up about half of this. So I'm going to go up 1 from here. From there, the sine function goes up to a maximum, then it goes back down to the midline on the quadrant line, and then it's going to go down to a minimum, but it's only allowed to go down 1 because my amplitude is 1. From there, I'm going to go back up to the midline, and this is 1 period of the sine function that got shifted up 4 and got shifted to the left pi over 2 with a period of pi. Okay, this is about as hard as the questions are probably going to get this year. The only thing I can imagine we do more is maybe flip across the midline, which would be multiplying by a negative. All right, if you have any questions, feel free to reach out and let me know what you have. Otherwise, go ahead and work on your WebAssign, and that is it for today.